we are going to see about reinforcement learning. And myself, Dr. T. S. Saran, Assistant Professor, Department of Computation Intelligence, SRM Institute of Science and Technology, Kantangalathu. And in reinforcement learning, we'll be seeing about the basic concept followed by the need for reinforcement learning. First, when we are going to see about what is reinforcement learning, it is very similar to supervised learning and unsupervised learning. We have another type of learning called as reinforcement learning. What is the main objective of reinforcement learning? It helps computer to learn by trial and error method. So what we have here is, it is basically feedback-based machine learning technique. Something you are doing, you are getting a feedback. If the feedback is good, you follow that. If the feedback is not good, you go for alternate option. And there is no need of any pre-program, and nothing is there because no one knows the environment. For example, what I can say here is, for ISRO is providing many satellites. They are sending the satellites to the moon, but no one knows the current situation of the moon. They are preparing a robot and capturing is done there. So at that time, no data is available. So something should be there to capture the functionalities in the moon. So what we are doing is, we are sending based upon some trial and error method. It fetches the information, and based upon the situation, it has to understand. It has to use some feedback based machine learning technique only. No one is ready to program, or no one is capable to program for the current situation of the moon, because we don't know what is the current situation available in moon. And reinforcement learning, the terms what we are going to see is agent, environment, action, state, reward, policy, value, Q value. Now we can see what are those terms. So when we are going for reinforcement learning, first one is agent, which is an entity that can perceive the environment and act upon it, can be said as an agent. Environment is an agent that is understands the situation. We assume the stochastic environment, which means that it is random in nature. Reinforcement learning learns from the experience only. No prior information, no prior program, no data set is available. Action. Actions are the moves taken by an agent within the environment. State. State is a situation returned by the environment after each action taken by the agent. Reward. A feedback returned to by the agent from the environment to evaluate action of the agent. Policy. Policy is the strategy which is applied by the agent for next action based upon the current state. Value is it is a long-term return with the functionality of the agent. Q value. Q value is nothing but additional parameter with current actions. Now, these are the parameters what we are going to use for reinforcement learning. Main factors what we think to be in a reinforcement learning. We want reinforcement learning to earn a lot of rewards, because when a movement is done, if it succeeds, we consider that as a reward. When a movement is done and no success is performed, it is considered a penalty. So what we think, no penalty should be there. What happens actually is initially there will be more penalties because the agent don't know the situation, it is unaware about the processing capabilities, unaware about the outputs. When it acts, it understands what is the expected output, and when it gets a penalty, it finalizes that if it is doing the current process, it may get penalty. So the penalty factor based conditions will not be taken by the agent in the next level. And agent should know what is there to get a reward. How the agent got a reward. What situations or what path made the agent to get reward. And here it is clearly saying that agent must select untested actions to discover reward producing actions. For example, a agent is producing a particular path and reaching the destination and getting awards. It should not follow the same mechanism at all the point of time because a same mechanism will not help you at all point of time. It should select some untested actions to check whether it is giving correct output or not, so that it can understand what are the possibilities to get a reward, what are the possibilities which make to get penalty. And agent must explore actions to make better action selections in future. So action should be made to better actions in the future. Reinforcement learning. Yeah, meaning of this is a environment is available, agent is available, the state is given from in the environment to the agent, and action is performed by agent to the environment. Environment performs actions and is given to the agent, and agent performs the state to the environment. When agent is succeeding in a proper manner, reward is given. If not, no reward will be given. It will be considered as a penalty. The target of a reinforcement learning is the agent involved should have lot of rewards. Compared with the reward and penalty, the reward should be more. That is the target what we have in a reinforcement learning. And approaches to implement reinforced learning: value-based approach, policy-based approach, and model-based approach. When we are saying about the term agent-based approach or value-based approach or policy-based, whatever approaches what we say, when we go for value-based approach, the main target what we have is we should find the optimal value solution, which is the maximum value at that state under any policy. We should find an optimal value function, which is the maximum value at that state under any policy. So that is called as value based. Whatever policy we are using, we should get best value. Policy based. Policy based is nothing but it should get maximum rewards. We can see about detailed description in the next slides. Model based. It is nothing but you are using some predefined mechanism. If you are using some predefined models. So what we are going to do is we are going to train, we are going to practice with some virtual models which can be predefined. For example, when Robo is going to do some actions. Before going to do into action, it should be trained with the virtual environment based upon our thinking capability. We think that moon will in this manner. So we think that this will be structure of the moon. Training can be given. Such a feedback based approach can be done with the model based environment. Policy. Policy is nothing but a mapping from the perceived states of environment to action to taken when those are in state. In reinforcement learning, uses a policy to select action given the current environment state. Here, what we are going to say here is we be having policies to make better performance. And reward should be the main target of the policy what we have designed. On policy and off policy. These are two type of policy what we have. On policy agent learns only about the policy that is executing. Off policy means the policies which are available and learning is done from the policies which are not executing currently. We think that when we are using this strategy, we may get a good resultant and rewards may be received. And that policy should not be used at all point of time. You should go for off policy such that we can take that policy and work it out and we can see whether we are getting a correct output or not. Because we cannot depend upon a single policy all the time. Reward signal. Reward signal is nothing but it defines the goal. It is nothing but appreciation. It can be said as a reward signal. For example, a dog is available. What you are going to do is you are going to ask the dog to do something. You are putting a ball and asking the dog to take the ball and come. It is nothing but training the dog. So that why we are training the dog? Because when we are playing a cricket, if ball goes to somewhere, dog will take the ball and comes to you. So what you will do at the initial point of time when you are putting a ball and a dog takes the ball and comes to you, you will give a chocolate to the dog or some biscuits are given to the dog. So dog thinks that you should happier if thinks that if ball is taken and given to the correct person, biscuits will be given. That is called as reward. It varies from situation to situation. So based thinking on the reward only, dog works in the next state. Similarly, it varies from person to person, situation to situation. So agent maximize the total number of words that are receiving over long run. So we should think about the maximum number of rewards received over the long run. And as a student point is going to be considered, you will be getting good marks, a good perspective on the staff, so that for a long run, they will help you for projects, for your letter of recommendation after completing a degree, it goes on. So each perspective has different rewards and the reward should be more for a long run. Value function. The value function, value of a state is the total number of words an agent can expect over future. So here what we have here is a reward signal simply indicates what is good in a short run. But while a value function indicates that what is good in long run. So short-term process can be service reward, but we are thinking about the long-term process. Example, I said about the dog. I am putting a ball to the dog and asking the dog to fetch that and come it to me. So why I am thinking that? I am thinking while I am playing game, this dog can be used to take my ball which I have used. So a long run, that can be said as value. Value can be indicates the good in long run. Value of the state is the total number of rewards the agent can expect to accumulate over future. And computation is done using the states that are likely to follow the current state and rewards available on those states. And here rewards are given directly by the environment. Each time the value needs to be re-estimated. So when you are going to re-estimate the values, because the time to time based upon the sequence of observations, the agent rewards increases or the penalty also increases. So there should be some sequence of observations to check the value of an agent. So when the reward increases, appreciations can be given. When penalty increases, corrections can be done. The final target is we should get a better output. Tools for reinforcement learning are OpenAI YM, TensorFlow, Keras, DeepMindLab, PyTorch. And advantages. And here what we are going to do is high order thinking, because trial and error, we are thinking about robot and we are thinking about solar, we are thinking about satellites, we are thinking about high order thinking. So all the things, all the informations are done based upon trial and error, and you will be getting accurate information. And the reason for getting more accurate is it is very similar to human learning, because human also learn based upon trial and error. Similarly, a machine also learns based upon trial and error. And here we can use, due to this learning capability, we can use it in neural networks. And as we are using the model constantly, what happens? A mistake is available. And when a mistake is available, that mistake can be rectified. Because what an agent understands, if this process is followed, we will not get the correct output. That should not be followed. So they found what are the mechanisms in which we will not get the output, what are the mechanisms we get an best output. Disadvantages. Too much of reinforcement causes overload, which could weaken the results. As we are going for reinforcement learning, trial and error, you are trying with all possibilities, trial and error, which may weaken the results. Because every time we are going for new approaches, surely there may be a weakened results. And as it is going for a largest complex problem, when we are using the same for simple ones, then it not be good. Because a simplest task can be done with many mechanisms. Complex task can be done by only some simple mechanisms. So as reinforcement learning can be used for high-end mechanisms, we can use reinforcement learning for high-end mechanisms. Then it requires plenty of data, involves a lot of computation, Because trial and error, multiple states are there, multiple mechanisms are there. We have a reward, we have penalty, states are maintained, multiple data are needed. As multiple options are used here, maintenance cost is high. So, we can conclude that reinforcement learning is best as it works similar to human based upon trial and error method. And applications, when you're going to see about applications of your reinforcement learning, it can be used for creating simulators, object detection, automatic cars, robots. And you can say about all the natural language processing, predictive text, text summarization, question answering, and machine translation, all examples of natural language processing that uses reinforcement learning. Netflix developed a new machine learning algorithm based upon reinforcement algorithm and to create an optimal list of recommendations.